Since a falling object moves along a vertical straight line, we can use the y-axis to describe its motion. Of course, there is nothing wrong with using x-axis for the vertical direction, but pretty soon we will be studying motion that goes on in both horizontal and vertical directions at the same time. So we might as well get used to using x for the horizontal and y for the vertical. This means we will still use the same constant acceleration motion equations. It's just that we will be using delta y to replace delta x for falling objects. Let's do a simple lab to measure my reaction time for my fingers. I have a meter stick here and my son is going to help me. This is how it works. I'm holding my fingers at 50 centimeter marking without touching the stick. He is going to let go of the meter stick and I will grab it as soon as I see it's let go. Okay. So I grab this at a 35 centimeter marking, which means during my reaction time, the meter stick has fallen 15 centimeters. See if you can use this information to find my reaction time. Again, let's start by listing the variables. The 15 centimeters is the distance traveled, so delta y equals to 15 centimeters. Because displacement delta y is a vector, it has a direction. For the falling meter stick, this is a downward displacement. People usually use upward as the positive y direction. If we do the same, our 15 centimeters downward displacement would be negative for the negative direction. We're looking for time t. For constant acceleration motion, we need to know three things. What are the two other things we know? We know that the meter stick was dropped from rest, so the initial velocity is 0. And for falling objects, we know that the acceleration is the g, the 9.8 meters per second squared. Since this is a lab, I'm not going to round it to 10. Acceleration is also a vector, and this gravitational acceleration points downward, because gravity pulls down and the falling objects accelerate downward. Therefore, we have to make this acceleration negative for the negative y direction. We have these three things, and we're looking for time. There is no final velocity involved, so this equation can be convenient to use. So delta y equals to VOT plus 1/2 AT squared. But before I can plug these numbers in to find t, I have to take care of one more thing. Can you tell me what that is? Yes, I have to convert this centimeters to meters, because I have meters here and I have to be consistent with the units. 1 meter is 100 centimeters. So this is negative 0.15 meters. Now I can plug them in. So delta y is negative 0.15, VO is 0, and then the acceleration negative 9.8. So this is negative 0.15 equals to negative 4.9 t squared. I just have to divide by 4.9 on both sides, and then I take the square root. Of course, the negative sign cancels. So this will give me t equals to 0.17 seconds, and that's my reaction time. Now, let me just add a couple more things before we finish. Let's plot some motion graphs. For the acceleration of this falling meter stick, the acceleration is a constant negative number. So the acceleration doesn't change. It's the constant negative 9.8. The velocity For the velocity versus time graph, its slope is the acceleration, which is negative 9.8. So the acceleration, the slope, has to be a constant negative number. The velocity starts from rest, 0. So negative constant slope. That's the velocity versus time graph. For position versus time graph, let's say the object starts at this certain initial position. The slope of this graph is the velocity, and the velocity starts at 0, which means the initial slope is 0. And then the slope gets more and more negative. So the graph looks like this. And if you remember from earlier, for position versus time graph, it is a downward curve if your acceleration is negative. Lastly, the coordinate system is something we can choose. We don't have to choose positive as upward. We can also choose down as positive y direction. Whatever we choose, we just have to be consistent with our choice throughout a problem. For this one, if I choose down as the positive y direction, my delta y would be positive 0.15 meters. And that means my acceleration would also be positive. So if I plug these numbers into the same equation, I'm going to have positive 0.15 equals to 0 plus 1/2 times 9.8 t squared, which is exactly the same as that one if you just cancel these negative signs. So I'm still going to get the time that's 0.17 seconds. So you can choose different coordinate systems and still get the same results. In these video lessons, to avoid confusion, I will use up as the positive y direction.